against the wind? Okay. It is, Jennifer? 8. So, what is then the distance that I've traveled? It is? Yeah. R minus W times 8. So there you go. This is how we fill out the chart, right? Because rate times time gives you the distance. Now, we have 2 variables. Guess how many equations we will need? 2. We will need 2 equations, right, Sophia? So what would do you know one of the equation? So we're doing a round trip, right? So here is New York. Here is Paris. So how far is from New York to Paris? They say it is? Yeah, so 6,800 kilometers. So who could tell me the distance? I mean, who could tell me the equation using that fact? 3 people. Caleb, 4 people. Caleb, what do you think?
Can have 6.8 times r plus w plus 8 times r minus w equals 2 times 6,800.
Yeah, if you do that, then you have one equation with 2 variables. That's not going to help you. So we need 2 equations. What's one of the equations, Scott?
R minus w times 8 equals 6,800.
Good. One of them is R minus W times 8 gives you 6,800. Good. That's one of them. What's another one? Kate?
8 times r minus w equals 6,000.
Oh, that's the one she said. So can you give me another one?
34
34 over 5 times
r plus w.
R plus W is equal to 6,800, right? Because they were only traveling the same distance, going back and forth, right? So, it is the same distance that we're traveling. So, going with the wind, you're still going 6,800 miles and kilometers, and then coming back is still 6,800 kilometers. Do you see how we get 2 equations? So Caleb, you don't want to combine them together because then, right, you have 2 variables with 1 equation. That's not going to help you.
Still, it's true.
But you can't solve it.
But it's true.
Okay. 1 plus 1 equals to 2. That's still true. Does that help with this problem? Okay, so please remember that you have to have 2 equations. If you have 2 variables, you need to have 2 equations. Okay. Yeah, and some equation could be true, but that doesn't help you to solve. Okay, so that's not good, right? These 2 equations will certainly help us solve. Now, how do we solve this? It looks kind of difficult because you got fractions and things like that. But if you remember one thing, Berge, what would you do to solve this?
Well, I'm thinking, I forgot what it's called, but the one where you have to cancel out one of the variables.
Oh, you mean addition method?
Yeah.
We can't do addition method yet. To cancel out one of the variable at this point, you would not. Okay, so there's one nice thing you could do before you, Kevin.
Could you divide 8?
Yes, first of all, you could divide both sides of this by 8. Why? Well, 8 goes into 6,800, does it not? Okay, nicely. So you could simplify that equation. So do you think you should simplify the equation as much as you can? Always, guys, always. What about the first equation? Danielle? That's correct. Turns out that you could multiply both sides by 5 and divide by 34, but better than that is multiply both sides by the reciprocal, which is what? 5 over 34. Because does 34 go into 6,800? Does it? Yeah, nicely. That's how I knew to multiply both sides by the reciprocal. So you must what? Simplify the equation. And notice how nice this equation becomes. When I divide the second equation by 8, I get r minus w equals to 850. And when I multiply both sides by the reciprocal of the fraction 34 over 5, I get simply r plus w equals to 1,000. Isn't that nice? So do you think you should always try to simplify the equation before you do any of the methods to solve? Yes, that's a good thing to do. Otherwise, it's going to be really difficult to solve these. Isn't that right? Does this make sense? Yeah.
So
Now you would use, oh, you want to use the substitution method or? Yeah, because look, you got positive plus w, you got minus w. Why not just add them together? Right, go ahead, everybody try. I'll give you some time to fix them. By the way, when I add them together, so many people, for some reason, what's r plus r, guys? It's 2r. Now, Did anybody put R? For some reason, people put R. Okay, if you ever forget to do that, write 1R, 1R. Okay, 1 plus 1 is 2. Okay, don't write R. And so when you add them together, don't you get 2R equals to 1850? Then of course you divide both sides by 2. What do you get as your R? Nita? That's correct. Now that is kilometer per hour, isn't that right? Because we use the unit kilometers for the distance and an hour for the time. If I know, is that what they want, or do they want the other one? Do they want the rate of the wind also? Yeah, how would you find the rate of the wind? Which equation would you use? In other words, to plug in. Dieter? The first one, which one? Tell me. Yeah, the first one, but then simplified first one, right? You wouldn't go back to the original one, would you? To plug it in? I will use a simplified, right, first equation, which is R plus W equals to 1,000. And so, of course, how many people got the wind speed? What is the rate of the wind? Yeah, Courtney? That's correct. Okay, so this you write as a sentence. I wrote the rate of the jet in still air, right? Means if the wind is not against it or for it with it, it is 925 kilometers per hour, and the rate of the wind is 75 kilometers per hour. Okay. Does this make sense? Any questions? Who wants to read for us number 2? Go ahead, Anita. Can you read for us?
The boat can travel 60 kilometers downstream in 3 hours. During
Yep.
the trip takes 5 hours. What would the speed of the boat be if there was no current?
That's right. So,
What happened?
oh, okay. So, what are the two unknowns? Okay, if the boat can travel 60 kilometers downstream in 3 hours, return trip. It's a return trip, isn't it? You go back down and come back 5 hours. How come it takes longer to come back? Anybody? Yeah. Yeah, you're going against the current if you're coming up, right? Against it. So, what are the two unknowns? Yeah, Scott?
Speed of the boat.
Speed of the boat in still water. And what else? Is that it? Is that the only? Yeah, Anita? Speed of the boat with the current? Okay, let's see. If I let x to be the speed of the boat, well, I mean r, okay? Which means the speed of the boat with no current means still water. We also need to know the what? Kev? Yeah, the rate of the water or the current. You know what I'm talking about? Now, using these two variables, Anita, you will find the rate of the boat with the current and against the current. Isn't that right? Does that make sense? These are the two variables. So just like example 1, instead of airplane, now we have boat. It's the same idea. Okay. Yeah, question?
Yeah, are we gonna have to do like tables on them?
Oh, yes. So because we got rate, time, and distance. Oh, and tomorrow, no. Okay. Maybe if I ask you some, but this section will not be on it. But I may give you something with rate, time, and distance. That's okay. So here we go. There are two scenarios where you're going with the current and against the current. See if you can fill out the chart. Okay. So it is a very good idea to do with the chart when you have rate, time, and distance. Okay. Okay. What will be the rate with current? The same way as before, isn't it, Tina? No, it will not be W because W is the rate of the boat. Oh, not W. W is the rate of the current, right? So what will be the rate of the boat with the current? R plus W. What about against the current? Yeah, do you see how it's kind of same thing every time we do this? Okay. Oops. Okay, then I want to hide this thing. Give me a sec. Then what about the time? What's the time for with the current? Look at the question. It is, that's right, it is 3. What about against? 5 hours. Okay. You see how that's, Then who could tell me the distance with the current? Yes.
It's
3 times R plus W. What about against? Anita? Yeah, you see how it's very similar to what we just did here? Okay. Now, how many equations would you need? Since we were using 2 variables, we need 2 unique equations, don't we? Okay. So, who could tell me one of the equation? Yes, Scott?
R minus W